Okay, let's get started. First, I wanted to let everyone know that this webinar is being recorded, so please just be aware of that if you put questions in the chat or in the Q&A function. Regarding questions, we will be answering questions at the end, but if you think of something during the webinar, please put it in the chat or in the Q&A. Additionally, thanks to those of you who submitted questions ahead of time, we will be addressing those as well, so there's no need to repeat those questions. So let's get started. Welcome to tonight's webinar, The Forever Problem PFAS and the Chesapeake. My name is Jackie Goodrum, and I am CLA's Associate Director of Legal Education and Virginia Policy. And I'm going to turn it over to my colleagues to introduce themselves.
Hi, I'm Evan Isaacson. I'm a senior staff attorney here at Chesapeake Legal Alliance.
Hello, my name's Haley Capone. I'm Development Coordinator at Chesapeake Legal Alliance and just really excited to be here putting on these webinars and look forward to hearing about some PFAS policy. So thank you.
All right, great. Evan, let's go to the next slide. So before we get into tonight's topic, let's talk about what CLA does. So the Chesapeake Legal Alliance is a public interest environmental law firm based in Annapolis, and we work throughout the Bay watershed. We have three main program areas. First is our Community Outreach Center, and this is through where we organize our pro bono legal services and our volunteers, attorneys who we match with opportunities throughout the Bay watershed to be advocates for Bay communities. We also have our Environmental Action Center, and this is through our program through which we do direct litigation on behalf of clients across the watershed. And finally, we have our Legal Education Center, which helps train attorneys and empower advocates to exercise their environmental legal rights. Next slide. So tonight's agenda, first, we're going to provide some background on what PFAS are, dig into what biosolids are specifically. I'll share about policy developments recently in Virginia, and Evan will talk about ongoing efforts to control PFAS in Maryland, and then we'll move into questions for the last part of the webinar. All right, I'm going to turn things over to Evan to get started on the background.
All right, thanks, Jackie, and good evening, everybody. So, yeah, just a little bit of background for those of you who are relatively unfamiliar with PFAS or forever chemicals, you may have heard them called. It's a class of actually thousands of different chemical compounds, over 15,000 and counting, which were first discovered by accident in the late 1930s, but were eventually kind of ubiquitous in our modern world by the 1980s. Unlike many chemicals that have been developed for industrial purposes, PFAS was first introduced into consumer products, most notably Teflon, by the 1950s, and it quickly expanded into many different uses as the number of different chemicals were developed for commercial, industrial, government use. Health impacts are many and varied. Again, with 15,000 different chemicals, it's impossible for scientists to study the impact of every single one and, its association or correlation with various diseases. But generally speaking, it's associated with elevated cholesterol levels, reduced birth weight, immune system suppression, kidney cancer, among other cancers, and many other disease links are suspected and are being studied as we speak. Scientists have known of the hazards of this class of compounds since the 1950s. Frankly, Stanford University researchers noted some harmful aspects of some of the initial PFAS compounds in the 50s. By 1961, one of the private companies that developed PFAS chemicals had noted its toxicity, and subsequent lawsuits discovered, some of these memorandums saying that they need to be handled with extreme care, but none of that, of course, was turned over to the public or the medical community. PFAS as a class of chemicals is really, the heart of it is this carbon-fluorine bond, which is one of the strongest molecular bonds known in organic chemistry. It's what gives that class of chemicals its use, and why it is so useful in many different ways, but it's also what makes it so harmful to the environment and public health. So I'm just including a few images from some consumer products that many of you probably recognize, especially if you're a little bit older. Scotchgard. It was obviously a product used to coat, many different consumer products from chairs and couches and carpets. Teflon, of course, that was the initial chemical introduced into the marketplace. Due to its heat resistance, it provided a really good sort of non-stick coating for kitchen appliances. All right, so just moving on from PFAS for a moment, we're going to take a departure into what are biosolids, because some of the most impactful legislation in Maryland and Virginia this year had to do with regulating biosolids and specifically trying to prevent PFAS contaminated biosolids from causing harm to local water quality and drinking water. So biosolids are simply the solid leftover of the sewage treatment process. Sewage sludge is basically just any solid substance that's coming out of those facilities, but it's typically dewatered or otherwise processed to reduce the weight, make it easier to transport. And that solid after the treatment process, when it's headed towards a landfill or a farm field for land application, it's generally known as a biosolid. There are millions of tons of sewage sludge generated in this region each year. A smaller amount, again, makes it as biosolids once the sort of dewatering process takes place. The question, might be raised in your mind: why are we even allowing this waste material to be applied to farm fields? It's a legacy of a much older decision from decades ago that utilities and farm community and our regulators kind of jointly made, that like all large waste streams, we have to figure out a way to most efficiently use that stream. So it was seen as win-win, right? You have a recycling of a waste stream, you have fertilizer for fields because these are nutrient rich, and it was seen as a win-win. But regulators and scientists have also long known that, like any other source of nutrient applied to farm fields, there's the potential for contamination of water, surface water and groundwater. And so the Clean Water Act has been regulating biosolids for decades in recognition of that hazard. It's not like many Clean Water Act programs. The biosolid program has not necessarily gone all that well, as evidenced by a recent Office of Inspector General report. This was from 2018. I'll just read a few choice sentences. EPA consistently monitored biosolids for non-regulated pollutants. However, it lacked the data or risk assessment tools needed to make a determination on the safety of 352 pollutants found in biosolids. 61 of them were designated as acutely hazardous. So, their inspector general kind of identified a persistent and longstanding problem of the inability of our regulators, EPA and state regulators, to fully evaluate the risk of applying biosolids on farm fields. So it is not just PFAS, although notably this report was from 2018, which is somewhat before the current focus on PFAS arose. And with that, I'm going to hand it back to Jackie.
Okay, thanks, Evan. Let's go to the next slide. So Virginia has a PFAS problem. This is not unique. All states in the United States have a PFAS problem. And we know that Virginia has a PFAS problem because the map on the previous slide showed all the sites where testing performed by the Virginia Department of Health or the Virginia Department of Environmental Quality found PFAS present in surface water, groundwater, and drinking water, as well as fish tissue. Let's go to the next slide. So this pervasive PFAS contamination is the result of both legacy contamination as well as ongoing pollution discharges. For example, for ongoing pollution, at present, DEQ allows parties holding Virginia Pollution Discharge Elimination System permits, VIPDs permits, to discharge PFAS into Virginia surface waters. Under the Clean Water Act, from which this program arises, this permit program is supposed to work by limiting the amount of certain pollutants that a polluting facility can discharge into our rivers, creeks, lakes, streams, etc. However, DEQ failing to include pollution discharge limits for PFAS in these permits They're doing this even though the agency has the legal authority already under the Clean Water Act to do that. And so that means that multiple Chesapeake Bay tributaries continue to receive PFAS pollution. This pollution of surface waters in turn also contaminates municipal drinking water resources like the Occoquan Reservoir in Northern Virginia, because our surface water resources generally serve as the source water for drinking water reservoirs. This is why it's so important to stop PFAS pollution at the source, at the point of discharge, which generally are industrial facilities, before it reaches our drinking water. This is also the most cost-effective approach to cleanup and puts the cost of cleanup on the polluter. The polluter is paying when we do this. Next slide. So, a key takeaway from Virginia's approach regarding VIPD's permits is that Virginia continues to issue these permits that allow PFAS pollution, and they're not doing anything to stop it, at least with respect to these permits. And there has been at least one lawsuit filed in Virginia thus far for failure to control PFAS in permits. And I'm highlighting this fact because we have an existing legal tool, the Clean Water Act, and an existing regulatory regime that we could use to address this problem. But at least in Virginia, the state environmental agency is reluctant to utilize this tool and this regime at this time. Next slide. So another permit program where DEQ could be limiting PFAS pollution is the Virginia Pollution Abatement VPA program that permits companies to land apply PFAS contaminated biosolids or sewage sludge on Virginia farmland. And as Evan explained, biosolids are a byproduct of the wastewater treatment process that are marketed and sold as fertilizer. And because most wastewater treatment facilities do not have treatment technology that can remove PFAS from wastewater, the end product still contains PFAS. An increasing number of farms that have used land-applied sewage sludge are found to be contaminated with PFAS. PFAS-contaminated farmlands take years to remove these chemicals. That's why PFAS are called forever chemicals, and it makes the land unusable and unsafe for the landowners, the farmers, and any individuals using or purchasing crops or consuming water adjacent to these farms. And this, we've seen this in Maine and in Michigan, where farms have been, and the land surrounding them have been damaged by PFAS contamination from sewage sludge biosolids. Now, DEQ could use its authority under the Virginia Pollution Abatement Act to require limits on PFAS that are protective of human health in these permits, but it is not doing so at present. Next slide. So let's talk about some more positive policy developments in recent years. So around 2022, Virginia started to actually legislate with respect to PFAS. Legislation from 2022 to 2024 has predominantly focused on providing funding for PFAS sampling. The dashboard that I showed in one of the earlier slides is a result of that, securing that funding for testing. Earlier legislation has also focused on PFAS reporting and assessment of sources of PFAS contamination in surface waters, as well as the development of an advisory group for how to address this problem. Now, in 2025, there was a reduction plan specifically for the Occoquan Reservoir, given the high amounts of PFAS that has been found in the drinking water reservoir there. And then starting this year, we have a new administration that has indicated concern about PFAS. Just last week, Governor Spanberger was signing bills, and she noted that PFAS is going to be something that we're probably going to be talking about for a while in Virginia because this is an ongoing threat. This is an ongoing problem. And so we look forward to seeing what those plans are and to working with the administration and the DEQ on solving this problem together. Now, PFAS also became a major talking point for legislators on both sides of the aisle this past session in Virginia. We had several bills that passed. HB, oh, sorry, can we go to the next slide? Thanks. HB 1072 clarified that local governments have the authority to require PFAS testing of biosolids within their jurisdiction. And this is a huge achievement. This allows local governments to have the authority to protect its citizens and its lands if it so desires to do so. Another small step forward was HB 1443 and SB, it's actually 386, that's a typo, sorry, which requires testing for PFAS in biosolids and limits the application of PFOA and PFOS if it's exceeding a certain level. These bills also required farmer notification of test results prior to application, which is a big win for the conservation community and for farmers because farmers have a right to know what's being spread on their lands, and this bill enables them to have that. And finally, another PFAS win this session is SB 138, which requires public wastewater treatment facilities and industrial companies and airports that use AFFF to test their discharges for the presence of PFAS each quarter. Now, none of these latter bills start right away, but it is nonetheless a small step forward and progress that we are happy to celebrate. Next slide.
All right. Is that on to me? All right. So I'll talk briefly about Maryland's legislative journey to regulate PFAS. So interestingly, I over a decade ago, I worked for the Maryland General Assembly and I was writing and analyzing environmental bills, and there was not one dealing with PFAS. And I left the General Assembly in 2015. For several more years, there was no, bills to regulate PFAS. And then all of a sudden, 2020, for whatever reason, just the floodgates opened. And between 2020 and 2026, we had 35 different bills. That does include cross-files. Cross-file bills meaning the companion House and Senate bill. So just a surge of interest in this issue and regulating this problem, probably beyond the scope of today's presentation to figure out why, like what caused that sort of moment in time where, interest in PFAS grew, given that we've known about the harm and hazards of, say, Teflon for decades. But anyway, the first legislation in 2020 dealt with firefighting foam, which is a massive source of environmental contamination of PFAS. So it's a good place to start. There was a limited bill to deal with cosmetic PFAS chemicals introduced intentionally into cosmetics. Another bill dealing with carpets, which is another source of contamination in the human body of PFAS. Pesticides, although it was just a study, playground surfaces. 2024 also had a bill that I'm somewhat familiar with to regulate the introduction or the discharge of PFAS from significant industrial sites into our sewer systems, which then, of course, discharge into our waterways. That bill is still being implemented to this date. Because there were a number of different timeline or deadlines in that bill, some of which have not come up yet. Last year, there was a bill dealing with regulating PFAS into our groundwater, like intentionally injecting water into our groundwater in order to recharge groundwater levels. And then this year, I'll talk briefly about the brand spanking new sewage sludge bill, which was a bit of a disappointment. I mean, we want to celebrate small wins, and this is a small win. Baby steps forward in terms of regulating, contaminated biosolids, which do, according to the EPA's draft risk assessment, harm farm families and adjoining properties through groundwater contamination and contamination of crops. This was sort of a multi-year effort. The bill in 2025 that was first introduced was a more classically designed to regulate at the at the point of application. So enhance setbacks in order to, create greater distances between where the biosolids are applied and where, an adjacent property line is, reduced amounts. And then if a certain amount of PFAS is found in the biosolids, it would just be a straight prohibition. This year's bill took a somewhat different approach. There is still some degree of regulation on the land application of biosolids itself, depending on how high the levels of PFAS in the biosolids are. It may trigger either a prohibition on the land application or some additional measures, such as the reduced rates of application. But a lot of the value of the bill is on the other end, at the source. So there will be going forward greater attention paid to the facilities that actually load the PFAS into the system in the first place. So we're not talking about the chemical manufacturers per se who manufacture the PFAS and introduce it into the environment in the first place via products. We're talking about those secondary users who might use PFAS in their manufacturing processes, but then otherwise discharge their wastewater into the sewer system. By trying to establish PFAS prevention or control projects at the source, it'll keep it out of our sewage treatment plants, which then means it's not going into the liquid effluent to our rivers or into the biosolids that are then land applied. It's a model that is roughly adopted from the Michigan approach, who was a few years ahead of Maryland and Virginia in this regard. All right. So clearly, Maryland's legislators have expressed a high concern over PFAS, 35 bills in 6 years, and a keen interest on regulating it. But as for the regulators themselves, the Maryland Department of the Environment, it's been more of a mixed bag. On the one hand, as I'll show you in a few slides, we've had some degree of good sampling data, especially of surface water and fish tissue. And we had a somewhat robust PFAS action plan to help control it. But on the other hand, when push comes to shove, when you actually ask the department to control PFAS at the source through a pollution permit under the Clean Water Act, the answer is generally just no. Unless and until they're required to, they'll sort of hide behind, scientific uncertainty. So here's just an example. We helped a partner of ours write permit comments. It's one of the things we do often. And we got, a letter back from MDE saying, no, they're not going to regulate PFAS through this permit, and here's why. Um, you know, EPA's adopted human health criteria for PFAS have not yet been included in the CFR or COMAR. So that second part is somewhat comical because COMAR is the Code of Maryland Regulations, and the department is the one who writes those regulations. So they're basically saying we haven't written the regulations, and therefore we cannot regulate it. It's a problem they can control. We worked with some students who are fairly adept at putting together maps, and we sort of brought all of the different PFAS data we could get our hands on from the state and other sources and combine it into a map. So here on this map, I'm not going to go through all of it, but you can see both the rural land application sites of biosolids. You can see industrial sources that are known to emit PFAS. You can see sampling locations where the state went out and took surface water samples and fish tissue samples to measure PFAS contamination in our environment. So we tried to integrate it all onto one map. All right, so the bigger picture here, I guess I'm striking a hopeful tone here in that PFAS are nothing that our regulatory systems were not already designed to handle. Congress didn't know what PFAS was, but they didn't care. They knew that they weren't going to be able to figure out what every conceivable pollutant ever developed would be. They just said, we are mandating through the Clean Water Act that our waters will be fishable and swimmable and that point sources of pollution will be eliminated. And it was agnostic to the type of chemical. And so our law, the Clean Water Act, and our regulatory system, the permitting system, were designed to control PFAS and any other chemical. And moreover, PFAS are not anything that our current technologies cannot handle. They're, the Clean Water Act was designed to be technology forcing, so it gives scientists and engineers an incentive to go out and invent new pollution control technologies, knowing that they would be adopted. And adopted, they have not been, but they were developed. There's plenty of technologies. I've listed a few on here. These are, I don't expect you to understand these processes. I don't myself, but things like granular activated carbon, you could find that in a Brita filter. Reverse osmosis, many people install those under their sink if they have a private well. These are technologies that existed for decades and that we can be adopting if we so choose. And then that's on the filtration side. On the destruction side, we had a number of questions come in asking about how do you destroy PFAS. Um, Basically, there's a lot of new and novel technologies being developed that I am not going to pretend to understand. But the more classic traditional approach is very high temperature incineration. So gasification or pyrolysis technologies, thermal oxidation. There's a lot of big words that I don't, again, fully understand. But if you heat up to a certain temperature, you break that carbon fluorine bond. And that's the critical key part. So the hopeful message here is no one can tell us that we don't have the laws or technology to solve this problem. We absolutely do. And with that, we're going to start taking questions. I don't know if any have come in by chat, but a number came in before the presentation started. So I will just start by running through a few of those questions and answers. So the first question, what do studies show so far about PFAS concentrations in water and sediment in the bay and in the shellfish, fish, and other bay biota? Um, so we're familiar with a few studies and data sets. I am not a scientist, nor is Jackie. We do have a scientist or two on site, including Haley, but we have not done a thorough scientific literature review. But I just listed a few of what I am familiar with. So for one thing, there is a multi-year study from the University of Maryland at College Park, where they have been collecting data from Marylanders around the state, sampling their own residential wells, testing for a number of pollutants, including PFAS. The results of that study are not out yet, but they may come out this year. Um, I am familiar with a number of academic studies on specifically biosolids and the fate and transport of PFAS in the groundwater. And I'll get into that a little bit more. I already showed you previously, both Maryland and Virginia have these maps of surface water and fish tissue samples. So you can go onto those maps. You can punch in your own address. You can look for your nearest stream and see if there's any results in your area where the state has gone out and sampled surface water. And I'll get into that in a second as well. Department of the Environment and Virginia DEQ are also requiring permittees to sample, not all of them, unfortunately, but in a select number of facilities are requiring them to sample as part of their regulatory requirements. So I mentioned surface water and fish tissue sampling. This is just a screenshot of a table that's kind of buried on the Department of the Environment's website. I wanted to just highlight a few rows here. So the highlighted rows are Piscataway Creek, which is a tributary of the Potomac River. And these values are just eye-poppingly large. So I put in the note here, just for context, under the Federal Safe Drinking Water Act, the maximum contaminant level for drinking water is 4. And we have surface water flowing down the Piscataway Creek at 3,192 parts per trillion of PFOS, which is just one specific analyte, one specific species or chemical of the PFAS family. And even if you go to the tidal headwaters of Piscataway Creek, which is where the creek is a fairly large river at that point and subject to tidal influence, you still had concentration of over 200. So, I mean, these are not just high, these are nationally almost outliers. That's how high they are. And they're not the only one. There was another site not right off the Chesapeake Bay, I believe in Calvert County, that had 10,000 parts per trillion. This is just a zoomed in version of that same map with a different background to make it easier to read. But this is Joint Base Andrews. And these are some of the sampling locations that MDE, the Department of the Environment, to their credit, went out proactively years ago and started sampling in these locations. And these are those tributaries to Piscataway Creek in the Potomac River where those exceptionally high concentrations have been found. Here's just an example. I'm not going to get into this, but the question asked about literature. This is one very recent study that came out discussing the fate and transport of PFAS on those fields where biosolids are applied. Um, and this is from a separate study, a nationwide study where researchers from, I think, Penn State and University of Arizona, maybe, where they tried to aggregate data from around the country to get a more representative sample. The left column, a bunch of non-detects of PFAS in the well water before application, and then you can see after application, it immediately jumped up in some cases to multiples of the MCL, the Safe Drinking Water Act threshold, like for PFOA, which is basically Teflon. All right, the next question. And Jackie, stop me if there's another question that came in that you want me to address first. But um, all right, what are PFAS regulatory limits and thresholds? That's a great question. My head gets swimming in all of these numbers, and because they use different units in different regulatory contexts, there's parts per trillion, parts per billion. Um, the most important one to probably understand is the Safe Drinking Water Act MCL. Those are actually regulatory limits. For PFOA and PFOS, it's 4 parts per trillion. Under the Clean Water Act, we don't have a regulatory limit per se, which is kind of what the Department of the Environment and Virginia DEQ hide behind when they say we're not required to regulate through this permit. Nevertheless, they do have draft human health criteria, which is, get ready for this, 0.0009 parts per trillion. So for PFOA. So that is an exceptionally small number. I don't even know how you sample that. I think that would be well below non-detect. In any case, the point here is it shouldn't be in the water in the first place. It is harmful at exceptionally low concentrations. There's a separate aquatic life criteria value under the Clean Water Act. Um, Various different regulatory frameworks, toxic release inventory, RCRA, I could go on and on. There's a number of different federal environmental laws that impact the regulation of PFAS, and the numbers are different for each. Um, so I hope that answers that question. But again, if this doesn't answer any of the questions that came in, please just email us and we can follow up with you. All right, the third and final question that I'm going to pre-answer here. My county is considering burning solids from sewage to a biochar type material. I am told that this process would destroy PFAS. Is this true? Does it pollute the air? All right, with the caveat that I am not a scientist or engineer and I'm not going to pretend to give a definitive answer here. I am generally familiar with these technologies. We've received several presentations, both from regulators like EPA, scientists, and also from some of the vendors of these technologies. Um, and the guidance continues to evolve. And there's a lot of caveats, but so the answer is highly case specific. Even within a certain class of technologies, you might read, no, it's not safe. It doesn't fully destroy the PFAS, or it destroys some, but not all. Others will say, yes, it destroyed all. I think the point is different companies, different vendors will have different products, even within that same class. Like not all pyrolysis plants operate the same way, not all gasification plants. There's different classes of technologies, but within them, there's different performance levels. Um, I think the most recent guidance I read from EPA suggested that for the most part, if they design these things properly, you can destroy most PFAS, if not all of them, by just destroying that carbon fluorine bond. But that the kicker is if you want to keep it from emitting the PFAS through that process, you have to have sufficient air filtration technology. So you have to have a bunch of add-on solutions. You can't just destroy it and expect that it's not going to then also have some air emissions that go along with it. So you have to get it right. It's not a simple process. It's a highly engineered process. And I think we have to get it right early because this is not, while there are some pilot scale projects out there, there are not a lot of large scale PFAS destruction units in operation that have been tested and vetted. And if some of the states or municipalities start moving ahead with one, but they move ahead with the wrong one, and then there's a horror story about how they contaminated the air quality of a local community, it's it's going to blow up in our face. We have to get it right from the get-go. The regulators need to be involved immediately and need to make sure that it is fully destroying the PFAS and not just shifting it from the waste stream to the air. Um, oh, I guess there was one more question. What are the past and active sources of PFAS? This is the last question. So they're everywhere. You know, the true original source is the manufacturer of the PFAS chemicals, the DuPonts and 3Ms of the world, and there are others. I'm just using them as some examples. But everything is a source because the key issue with PFAS, in case we haven't already said it, is the persistence. The chemicals are persistent in the environment. They just keep cycling around and around and around. So we're all sources, and you have to break that cycle. Destruction technologies is certainly one way of doing it. Filtration at the plants is another way of doing it. And then ultimately, once you filter it out, you do then need to destroy it. We have to create these sinks in the system to go along with the sources, or it will just keep cycling and growing and getting bigger because again, they do not biodegrade, they're not destroyed. They're found in all corners of the human body and all parts of planet Earth, including the bottom of the ocean and the top of the atmosphere. Um, so with that, I will stop. I don't know, Jackie, if there are any other questions that came in.
No, we had no other questions come in.
Okay.
We do have a few more minutes if people want to put some questions in. I wanted to highlight a couple resources that I put in the chat if you live in Virginia. First is the PFAS sampling dashboard. That is a compilation of the data that the Virginia Department of Environmental Quality and the Virginia Department of Health have collected in their sampling of surface waters, groundwaters, drinking waters, and fish tissue throughout Virginia. So that link is in the chat if you would like to access it and look through that data on your own. Additionally, the second resource is a resource from the conservation group Allegheny Blue Ridge Alliance. They do a lot of great GIS and mapping work, and they have compiled a map of all the land application sites across Virginia, and they found that there were nearly 10,000 sites that they could find, and that map shows where these sites are, so you can look and locate and see if any of those sites are close to you. Just like with the PFAS sampling dashboard, if you want to see what PFAS levels have been found in your area close to you. I will say with respect to the sampling dashboard maintained by the state, the sampling has been very limited. There is some data, but this has not been regular annual sampling by any means. It has been like a little bit here, a little bit there. It's still useful. We can get a sense for what the picture looks like, but ultimately more data would be great.
Yeah, it's the same in Maryland. That surface water sampling, I mean, that's part of what makes some of those exceptionally high levels so frightening is that that's just one grab sample. Who knows if they had taken 100 samples, what the range would have been. But yeah, it's certainly I would echo that point that we need to invest in a lot more sampling.
Mhm. And one final note on PFAS sources and, potential risk and exposure, and one more source I'm going to throw in the chat in a second, is fish consumption advisories. In Virginia, we have two areas where the Virginia Department of Health has issued fish consumption advisories in the past year due to the presence of PFAS, specifically PFOS, in fish tissue samples that it has taken. And the first one is in White Oak Swamp in the Chickahominy River watershed. And the second one, which is a very new advisory, is in the Occoquan River watershed. And I'll include a link to VDH's website where they post such advisories in the chat, just as another resource of where you can find sources of PFAS contamination close to you, or hopefully not close to you. But
Right. Well, with that, if there are no further questions, thank you all for joining. We hope this was informative. And again, it was recorded and we will distribute a recording probably tomorrow. So thank you all for joining and have a good night.